All right, so in this video, I'm going to show you how I use Arcjet to secure my applications. Now, Arcjet helps you implement bot protection, rate limiting, email validation, and more in just a few lines of code. We're going to see examples. It's customizable protection for forms, login pages, sign up, API endpoints, and all of your entire app, that you could test it locally instead of breaking your production. So I'm going to jump to the documentation, talk about the architecture of the Arcjet and what it is and how we would use it. And then we would see some example codes, the links in the description to the Arcjet and documentation. So definitely check that out. Now, before we go ahead, I want to go to the architecture and understand what Arcjet is and how it is built and how it is different from your traditional attack protection that you get out of a CDN, for example, that sits as a firewall in between the requests coming into your server. Now, Arcjet has been architected with a few key principles. So first of all, the proper security protection needs to have the context of the request, which is why these rules on protection should be located alongside the code. So they should run alongside the code that they are protecting, so they have access to the context. Let's say you want to check the specific user that's logged in or check their quota against your database. Your security code needs to run where your code is running, and Arcjet is kind of built with this in mind. Now, they should be easy to test. We have touched on it, that you should be able to run these tests or protections in development, not only in production. So that's another thing. And then it should be easy to install and add minimum latency to your application. We're going to talk about how the Arcjet SDK is going to try to run locally and decide locally as much as possible, and then only reach out to the API when it is needed, depending on the rules that you define. So therefore, it minimizes the latency. It also uses caching to, again, minimize the latency that it adds to your application. Now, Arcjet has a few core primitives that you can use to protect your app. You can use them independently or together. There's the shield protection, which protects against common attacks like SQL injection, cross-site request forgery, and whatnot. Rate limiting, bot protection, email validation. It detects sensitive information and redacts the sensitive information all locally inside your server without ever sending it outside of that. Now, mainly Arcjet is built on top of two components. There's one, the Arcjet SDK, which is what you would install and runs in your code. It allows you to configure different rules. And then there's the Cloud API, which is used to sometimes make decisions about whether or not to block a request, but also sometimes for reporting. So when the decision has been made locally using the SDK, it also sends the decision to the API so you can see in your dashboard what's going on with your application. Now, the SDK, as I mentioned, it integrates Arcjet into your application. It runs alongside your code. It can be inside of a middleware layer, specifically if you're in the context of a Next.js app to run for the entire app. Or it can be directly inside of the code, for example, inside of an API endpoint, which we're going to see an example very shortly, to run just for that single API endpoint. So you can inspect the response that comes back from the SDK, and then you can decide whether to block this request or do more advanced stuff like flagging an account for review, depending on what you have detected from this request. Now, the SDK runs a module that allows you to decide about these requests for whether or not you want to block the request locally as much as possible in your environment, in the serverless function, or however you're deploying your functions. Where possible, a decision is made locally and then reported to Arcjet so that it minimizes, again, the latency added to your application. Now, a typical local analysis, it would be that a client, this is a browser, a user of your application, makes an HTTP request to your application. A platform applies standard DDoS protection through their network firewall. So if, for example, you are deploying to Cloudflare or Vercel, they do come with DDoS protection out of the box. So that's like a network firewall that sits in between the request and your application code. And then if it passes through that it comes to your server, which is where the Arcjet SDK is configured to run as a middleware. So it intercepts the request. It has the context of the request and the code in your application. So it makes a decision. And then if it decides to allow that request, then the SDK returns the response back to your application code and acts normally or blocks it. And then you can decide what response you want to return. A nice diagram here showing a request coming from the client, coming in through your network firewall. This is your DDoS attack protection from, let's say, Cloudflare as a CDN or Vercel. Then Arcjet SDK runs once it passes through that, and then if it's allowed, your application code runs, and then depending on if whether or not Arcjet made that decision locally, it is going to report back to the API so that you can see what is going on in your application in your dashboard, or sometimes you need to hit the API to make that decision, so that API call is also happening there inside during the evaluation part of that request. So you can contrast this with traditional CDN security that again sits as a firewall, doesn't have access to your code or the request fully. Sometimes it may result in false positives or false negatives. They may allow a request that they shouldn't have, or they block a request that would have been otherwise allowed because the user is logged in, for example. If it reached your server, you could have made a better decision. So Arcjet really gives you more flexibility. You can decide what you want to do. You get the request inside of your code, run the decision, get the report back, decide what you want to do right then and there. So it has greater flexibility in terms of what you want to do or how you want to protect your applications. It also talks about the Arcjet Cloud API. This is the API that you either run or hit for making decisions, or just report back asynchronously so that you can have the kind of overall view of what's happening inside of your application through your dashboard. Now, some of the rules, when you define them, for example, a rate limiting rule is going to only happen using the API. So this cannot be made locally because you want to keep the client state up somewhere using a Redis, let's say, store that's managed for you by Arcjet. So you don't have to configure this yourself. But this cannot be made locally because you need to have this state that is persistent across multiple requests so that you can perform rate limiting. So for specific rules that we can run that we're going to see in a second, you need to use a cloud API. All of this to say how Arcjet works really, and then how it ties into your application. There's different components that runs, but there's this example page in Arcjet which we're going to go through. We're going to have other videos on the channel coming up after this that we're going to implement Arcjet in specific use cases. For example, a sign-in form, a sign-up form, where we are going to protect specific API endpoints against bot protection or email validation and whatnot. But in this video, we're just going to try to shape an understanding of what Arcjet is, how it works, show some examples for you to test and try out for yourself. But if you're interested in more dedicated examples, specifically for Next.js, stay tuned as more videos would come up. Now, before I go to the example page, which is really great, something that I really like here is inside the documentation, you can see the SDK reference. You can run Arcjet inside of your Node.js backends as well. So definitely have a look here. But there are some integrations that are very interesting here. For example, you can integrate Arcjet to Auth.js or NextAuth, which is a very popular authentication provider for Next.js applications, in that you're going to use Arcjet to protect your sign-in and sign-up forms or endpoints, really, against brute force attacks and other abuses. It also ties nicely into Clerk. So whichever authentication you're using, there is an integration between the two. There's an integration for Vercel as well. So once you install it or integrate the two on Vercel, it automatically connects or uses your API key for that specific project in Vercel. That allows you to just apply anything that we are learning here, or apply the same protections to that Vercel project. So let's go to the example page. This is from the documentation. You can go to the examples. There's blueprints and examples here, but also from the main page, I guess, up here on the hero section, there's this live examples that you can click on that takes you into this page. Now we're going to review a couple of the examples together, but you're more than welcome to look at it yourself. We have the sign up form protection, bot protection, rate limiting, attack protection, and sensitive info. Now the sign up form protection actually has these three inside of it. So let's look at this, what it is doing. So this is going to include email verification. It is going to block disposable providers and ensure that the domain that the user provides, beyond the simple email verification, it also has an MX record, so it checks to see if this is actually a valid email provider. It rate limits the request to 5 requests over 2 minutes, and it also has bot protection to stop automated clients from submitting the form. So it really has 3 different rules, or a rule that uses 3 different primitives of protection in this sign up form. So here inside of the try it example, you can just hit sign up. This is non-existent, and Arcjet, this is just a dummy API. That's not a valid email. Sorry, not API, email. So if you hit sign up here, it runs against the Arcjet SDK. It says we couldn't sign you up. Your email domain does not have an MX record. It also detected that I'm from Canada. Now down here, you can use different emails. So for example, if I use a valid email to say hello at hamidbahram.io and sign up, it detects that that's a real email and doesn't send me anything, but it just passes through. There are different things you can do here. So for example, here we don't have a valid email. That's just the most basic email verification. It just says the email is not valid. Now this other one is actually a valid email, but it is from a disposable provider, the ones that provide you an email and it's disposed over 24 hours or whatever. So it again detects that it's a valid email, in that there is a valid MX record for it. The user can actually, I don't know, maybe receive something, but it's disposable email. I don't know really if you can receive emails from disposable emails, but you get the idea. Now down here, you can also see the code. So inside of the API routes, we have created the client. So let's just go to the code. I actually have the code over here open, so we can understand how it works. Again, there's going to be a video on the channel where I implement Arcjet in a form. We're going to have server actions. And good news, Arcjet already supports Next.js 15 and server actions. So you can run them inside server actions. You can run them inside your API routes or inside your middleware, depending on how or where you want to protect your application. And we're going to have a video coming up specifically implementing Arcjet in a form context. So where you're submitting a form, whether it's a sign-in, sign-up form or a regular contact page form, where we're going to implement bot protection and all of these different rules. We're going to look at server actions in the context of the Next.js 15. So stay tuned for that. But as an example, so inside of our post and API endpoint, this hypothetically is an Next.js application where we have this route handler for a post request. So the first step, we are creating a main Arcjet client by getting the Arcjet out of the SDK, and we're defining different rules here. Now, inside of the lib, we have defined our main instance of our client. So let me just go back, if I can, to the lib, or let's say maybe inside of the sign up and the test. Or maybe it is one level up here inside of the lib. So we have defined this Arcjet client over here. We gave it a key. This is the key that we get out of when you create an account, you get your Arcjet key. You could just pass it here and create an instance of the Arcjet. Now here, as you can see, we haven't defined any rules, and this is what we're going to define or extend this client on every specific API endpoint or protection that we need later on. So let's go here now to our app, I guess, and signups. I think this is very weird. Test. And then let's go to this route. Okay, so let's make this a bit bigger. So here I'm importing that same Arcjet from the lib. So I get the main instance that we created from Arcjet. And now we are extending it with a rule. So if you have the protect sign up rule, it protects against email verification, bots, and rate limiting. As you can see, you could just define the rule over here. We are also using Shield. So Shield detects suspicious behavior, such as SQL injection, cross-site request forgery, scripting attacks, and whatnot. And all you need to do now inside of your post route handler, which is a function you export from your Next.js route.ts or JS file, mapped to a specific HTTP route, in this case post. And then what you do is first, I guess we're doing a simple schema validation using SOT, but then we are actually passing the request and a fingerprint that we are creating out of the user ID or user IP here to the Arcjet and call the protect function on it to make a decision. So depending on how you want to track the user, here we're using fingerprint and using the IP from the request. If the request doesn't have an ID, you can use this IP, which is a util function from the Arcjet SDK, and you pass a request object to it to get the user IP. And then we're using that to create a fingerprint of the specific request for a specific client, and then run the protect function to decide whether or not we want to allow. Now, this decision comes back with functions such as is denied, and then reasons for why it was denied. So you can really you narrow down what you want to do depending on why exactly this decision was denied. At the very basic, you can block, or you can flag this specific account for, I don't know, further investigations. So as you can see, there are different if checks, checking to see if the decision was made because of the email, was it made because of the rate limit, and whatnot. And depending on that, we're just returning different Next.js responses to our clients. Decision is errored. If maybe none of the other reasons was the reason, and we just didn't have a valid key there. So you get the idea. It's the whole thing is that you can dynamically set different rules. You have access to your request context. You have access. If this is for a logged in user, you have access to your logged in user. You can check your database and use those information in the decision and what you're returning or what you're doing with this decision. And that's where the power of Arcjet shines. Whereas if you're using a firewall, a network firewall that runs before the request even hits your application server, it doesn't have access to the context of your application, and you can't really customize it. It either blocks them or allows them. You don't know why it was allowed or why it was blocked. And more importantly, you can't really detect a specific logged in user or check their quota inside of the database, which I think is really great. Now, if you go back to the example page, there are more examples here for bot protection. We've already seen this inside of the form, but you can run curl commands against this. Curl is considered to be a bot. So if you run this, it is going to block it. You could run it and test this locally for yourself. Actually, let's just run it together. So let's run this command inside of here. Let's make this a bit bigger. I hope you can see. So if I run this, you can see this was forbidden. So the response that we got out of this was forbidden. So it was detected as a bot. And your IP will be blocked for 60 seconds, meaning that this is now tracking you or your request or you as a client and keeping record of your fingerprint. So if you're trying to make this, it detects that you're also trying to somehow abuse the system and it protects or blocks you for 60 seconds. Now, this can be run inside of a middleware in the context of an Next.js app, for example, to protect your entire site, or in a specific endpoint, such as sign in, sign up, or any form that you are receiving. So you can play around with these examples. The rate limiting is a similar concept. You can test this with a specific number of limits. For example, I have 2 every 2 minutes, I guess. If I push it again, now I have 0 requests because I had pushed this 2 times. Now this resets in 51 seconds. If you then sign in with GitHub as a logged in user, this quota changes, maybe it becomes 5 requests per 2 minutes, and you can test that out. Again, this is Arcjet from a high level, how it works and how it's customizable. You can run these codes and rules dynamically inside your application server, where you have access to the context of the specific user and your database. But we're going to have more videos, as I mentioned, in future, implementing this, specifically building from scratch inside of a form in Next.js with the new form component with Next.js 15, using server actions, and all the good stuff in Next.js 15. So stay tuned if you're interested in that. Other than that, if you have any questions, hit me up in the comments like always, and I'll see you guys in the next one. Bye-bye.